Good afternoon, everyone. Hello, am I audible? Good afternoon.
Actually, like fifth semester.
Okay. So, so we were on this thing, no? We have talked about the maximum wheel load, where should be our maximum wheel load, and obviously when you know the position and the of the maximum wheel load, you can definitely find out, calculate the reactions, and find out, okay, the maximum load on the crane system. Now once you know the maximum load which is acting, you can find out the maximum shear force. If I talk about the maximum force, suppose Suppose you have, this is the gantry girder. Here you will have your reactions of the on the gantry girder also. Reactions will be there here on the gantry girder. Then the span of the gantry girder will be known to you. This span will be known to you, which is the span of the gantry girder. We will have the this this will be your suppose span of the gantry girder. You have your RA, because I told you the we had taken what we had taken the sorry we had taken the we have given some points to the gantry girder and the crane girder. So on the gantry girder, if we had given this to be as point A, this to be point B, and on the crane girder it was C and D. So reactions RC and RD we had calculated, right? So here also we will have a UDL here. Okay, we have a UDL here. Okay. This is the UDL on the gantry girder, the sulfate of the gantry girder. Okay, sulfate of the gantry girder. Sulfate of the gantry, plus we will have our rail section. If I write at the bottom, rail per meter. Okay, so this is the sulfate of the gantry girder plus the rail section which will be there, because we know I told you if this is your gantry girder, this is your crane girder. Here will be your trolley or the crab. So we had uh, on the gantry girder we will have what the sulfate of the gantry girder as well as the weight of the rail section is going to come. Rail section is above the gantry girder, where this crane system is moving from here to here, from here to here. Okay, now on the crane girder, you see here, this is the crane girder, this portions. Okay, this is your crane girder, sorry, the gantry girders here, these things. These are your gantry girders, which are unsupported beams. Then we have this as your crane girder. Now, on the gantry girder, you see here, this is the crane leg of the crane girder, here one, here one. So this is obviously going to move in this way and this way. So now where we get the shear force maximum, we had the load when we were checking for the crane girder C to D from here to here. We had got in the approach, minimum approach here, it was the minimum approach from here to here, and we got the maximum load, right? Okay, now this portion, these two legs of the crane girder are moving here on the gantry girder, and so the gantry girder will have the maximum shear here at the end, okay, on the edge. We consider it to be here. This, if you suppose this is your RC wheel of the this crane girder which is moving on the rail section. So we can say this to be RC by 2, and this also RC by 2. Why? Because the reaction, you remember the last class we have, the first class, in the first class we had calculated the maximum load, and the maximum load, or you can say the reaction after, the reaction what we had calculated, the reaction was RC, the maximum, which was maximum RC. uh, at that section you would have got for the maximum load at minimum approach distance. Now for per wheel it was that much load. Okay, so this is the leg of the wheels of the crane girder, which the maximum reaction was RC by RC. So we will have to divide this to the reaction on both the legs or these wheels of the crane girder. So RC by 2 and RC by 2. We can consider it to be this distance. This distance will be this one. I cannot make it short. This distance will be how much? This distance will be, suppose we consider it to be B. Okay, B. That is the wheelbase. This is known as a wheelbase. That means the distance between these two wheels of the crane which is moving on the gantry girder in this way. Here, the distance between these two wheels, that means these two wheels, distance between these two wheels is your B, which is known as your wheelbase. Okay. So in this way, when you know your span L of the gantry girder here, the UDL, which you know, the self rate of the gantry girder plus the rail section which is on the gantry girder, that, and the reactions, sorry, the this loads from the wheelbase which we had calculated, which is falling on this gantry girder, moving on the gantry girder, and we assume our shear force to be maximum here, because the shear force is maximum at the edge, at the supports. So we have here, we can calculate now our Ra and Rb, the reactions. When you know this UDL, the span, the RC by 2, RC by 2, the wheelbase, you know the distance of the wheelbase, you know, then easily you can calculate your Ra and Rb, and from which you will get your maximum shear, sorry, the maximum shear force you will get. We know the maximum shear forces at the support, so we have placed our wheel base, that is the wheel base of the crane system, to be at the edge or at the supports of the crane girder. Okay, so this was your, this one. So this was your maximum shear force. In this way, from this you can calculate now the maximum shear force. In the first class we had calculated the maximum load, wheel load, you can say the maximum wheel load, the maximum shear force we had calculated, we can calculate in this way. Another most important thing is that what will be the maximum bending moment. Okay, what will be the maximum bending moment and where will that be? So now we will go and check out how to find out the maximum bending moments. So this was your maximum shear force. So now if I'll erase these things now, let me show you now for bending moment. Okay, so now again if we do for, now suppose this is your gantry girder here. Okay, here is your reaction on the okay, sorry. So this is your reaction on the gantry girder Ra. We have Rb. Okay, another thing which I is, suppose not suppose, this is your Okay, this is your span of the gantry girder here. Now the center, this one, the center of the gantry girder. Suppose the center of this is the gantry girder, span of the gantry girder. Suppose the center is somewhere here of the gantry girder. This is the center of your gantry girder. Okay, so suppose this will become your RA, this will become your RB, because the reactions RA RB we had taken to assume the point there on the gantry girders. This is your span of the gantry girder. Suppose L it is. Okay. Then we will have a UDL here. This is the UDL of the gantry girder plus the rail section like the previous one for the shear force how you have calculated on the gantry girder. So this is your self weight of gantry plus rail kilonewton per meter. Okay, so this was your center. Let me name this to be C here. Suppose this was your C, center of the gantry girder, right? And we are finding out now the maximum bending moment. Okay, where and how much is your maximum bending moment? So how much is your bending moment, maximum bending moment, we have to calculate from these once we figure out where are the loads, etc. Okay, so you can obviously calculate the maximum bending moment from here, but where we will get our maximum bending moment, once we know the position, then we can find out the we'll get the distances and we can calculate our maximum bending moment, right? So here we know this is the gantry girder. Above the gantry girder was what? The rail section. That's why we have self weight plus the rail section. Above the rail section is what? The wheels of your trolley. That sorry, not trolley, the crane. If you see your gantry girder, your crane girder, this are your crane girder. This is here your trolley. Okay, so this is your trolley. So we have on the gantry girder, we know there is a rail section above this, as well as this crane girder, which is moving from here to here, this way, this way, this way. So this obviously have wheels on it. Here one, here one, here one, here one. At each end of this leg, there is one wheel, one wheel. That means there are two wheels on each gantry girder, right? So this crane girder is moving from here to here. Okay, this one, if you see from here, from this side, if you see, from this side, if you see, this is your gantry girder. This one is your gantry girder, and these are the two uh, wheels of the crane girder. Okay, here one and here one. So somewhere here, this will be your crane girder wheels. Okay, now but where is your maximum bending moment? Because wherever will be your these wheels of the crane girder, there we have to find out the maximum wheel load, because we have calculated the maximum load from the trolley on the crane girder. Now from the trolley, it will shift to the crane girder. From the crane girder, it will go to the gantry girder. Now on the gantry girder we have the this thing, the crane girders are going to give the loads, this crane girder. So wheels of the crane girder have to be there. Now Where is your maximum bending moment? Okay, your maximum bending moment, suppose I'm telling you here, your wheels of the crane girders, if I take it to be here, suppose now if I tell you your wheel of this one wheel here, this one of the crane girder is here. This is your crane girder, one wheel. Another one is here. Okay, so you have your two wheels here. Suppose this wheel is A, this wheel is B, and we know this is your wheel B. We had calculated the RC. So this is your RC by 2. We know each wheel is carrying half of the maximum reaction, RC by 2. So here one RC by 2, RC by 2, RC by 2. Okay, this is the center of the gantry girder. Fine. We have the UDL here. Now this is the wheelbase. Suppose your wheelbase, this is the distance of your wheelbase. This one, the wheelbase, suppose this wheelbase is how much? This is suppose B. Okay, we had just now before this when we were calculating the maximum shear force, we had already mentioned that our distance between these two wheels of the crane girder is B, the base, you can say wheel base. This is known as your wheel base. Okay, the wheel base is how much? That means the distance between the this wheel and this wheel is B, suppose. Okay, now where is your maximum bending moment? Your maximum bending moment will be in this place where you have to place these wheels of the crane girder in such a way that your, okay, one more thing. Mm. Suppose I'm giving this to be green. Um, Blue. And now see, these two are the wheels of the crane girder. That means this from here to here, this distance from this wheel to this wheel is this distance, is this wheelbase B. Now the center of these wheelbase will be where? Here somewhere. Okay. So this is the, mind it, this blue line is the center of this wheelbase. That means here. That means here. Array. That means here somewhere. This is one wheel, this one, this is another wheel here of the, okay, wait. This was your, suppose, the crane girder. So you will have here. Okay, fine. Just here is your one wheel. Here is the other wheel. Okay, and here this is the center of your wheel. Okay, these two are the wheels, this is center. So these two are the wheels, these two wheels of the crane girder. This is the center of the wheel. That means this is the center of the wheelbase, and this green one is the center of the gantry girder. Now your wheels, that is the wheels, the crane girder wheels, must be placed in such a way to get the maximum bending moment. Your these two wheels of the crane girder must be placed in such a way so that the distance, this is the C, the distance from the distance of this C of the gantry girder, the center of the gantry girder from the nearest wheel, this, and the center of the wheelbase should be equal. Okay, your maximum bending moment, where is your maximum bending moment? Your maximum bending moment will be there where your distance between the CG of the gantry girder to the nearest wheel of the crane girder, and the distance between the CG of the crane girder to the center of the wheelbase, when these two are equal. That means now, that means this distance from here to here and this distance from here to here are equal. Okay, now if I say equal here, what it can be, blue color, suppose I take. So now this was B. Okay, and another thing is what, if I take this. Okay, so this was B. Total, this total distance from this wheel to this wheel, A to B, is the wheelbase, this one. From the center, obviously you will know this, this distance and this distance, these two distance will be how much now? When you, this is your wheelbase from here to here, it is B. Now this will be how much? This distance will be obviously B by 2, half of this wheelbase, because this is the center, right? This blue color is the center of this two wheels, center of these two wheels. So this is half from here, half from here. It is B by 2. Okay, b by 2, b by 2, half half. Now when your wheelbase or the wheel one is placed in such a way of the crane girder, such that your this center, this one, and which was the, which is the center, this is the center of the gantry girder. So it is placed, this wheels are placed in such a way so that this CG, this center, from the center to the nearest wheel of the wheel, crane wheel, from here to the center of the gantry girder to the center of the wheelbase are same. That means if these two are same, I mean to say, if this distance from C to A and C to this distance C dash, suppose if I give it to be C dash, if I say this to be C, suppose CW, if I say C, suppose the center of the wheel, okay. If I say center of the wheel, now the distance from this center of the gantry girder to the nearest wheel and the distance from the center of the gantry girder to the center of the wheel is same. That means here it will be how much? This was your b by 2. This distance was b by 2. From here to here, it is b by 2. So that means this will be how much? If we divide this into b by 2 into again 2 halves, it will be b by 4, and this will also be b by 4, right? So you have to place your crane girder wheels in such a way so that your CG of the gantry girder, distance of your CG of the gantry girder from the nearest wheel, and the distance of the CG of the gantry girder to the CG of the wheelbase should be same. Okay. Once you see this figure, once you get this, once you know this, that means your maximum bending moment. Where is your maximum bending moment? Your maximum bending moment is here at this wheel A, because it is nearest to the CG of the gantry girder, and the distance you have to place your wheels above the gantry girder in such a way so that your this two distance are same. Okay, the distance from the CG of the gantry girder to the nearest wheel, and this distance of the CG of the gantry girder to the CG of the wheelbase. Okay, so once we know now these two are equal distance, so here will be your maximum wheel load. If I see here here will be your maximum bending moment. Okay, maximum bending moment will be here, which is nearest to the CG of the gantry girder, and this CG is equal at an equal distance from the CG of the wheelbase. Okay, it is not necessary that always you will place this A wheel near to the C. Okay, nearer to this C of the gantry girder. You can also place your, suppose if I say you, suppose this is your gantry girder, this is the center of the gantry girder. You are placing your wheel base. Here is one wheel base, another one is here. Okay, like here you see this wheel is nearest to this CG of the gantry girder, which is this. Now you see, now what you'll see here, if you see, suppose this will be your CG of the this two, the wheels. So now this is the C of the gantry girder, this is the C of the wheelbase. So what will be your maximum, where will be your maximum bending moment? Your maximum bending moment, your maximum bending moment is going to be here. Your maximum bending moment is going to be here. Why? Because this distance, this one, this is the CG of the gantry girder, distance from the CG, this distance and this distance from the CG of the gantry girder to the nearest wheel are same. We have placed these wheels in such a way that your this distance is equal, this two distance is equal. So our maximum wheel bending moment will occur on now on wheel B, which is nearest to the CG of the this one, the gantry girder, right? So once you know this, you can obviously find out your maximum bending moment here, because you know the reactions you have to find out. You know RC by 2 from the maximum load wheelbase. You will know the distance between these two wheels. You will know your UDL of the you will know your UDL of this sulfate of the gantry girder plus rail. We have b by 4. This distance you will get from the wheelbase again. You know the span of the gantry girders. So what will happen? You can find out the reactions RA and RB. Once you know moment, you can find out RA, RB. Then again, what is the moment here? MA. You can find out. You can calculate here. So this was one of the important thing which you should know in your gantry girders. Okay, which was, first was your maximum load, next was your maximum shear force. How you going to find out the maximum bending moment? Once you know the figure, you can where is your UDL, where is your reactions, what is the distances. You can find out the shear force. You can also find out from this figure when you plot this, that is, you have your reactions here, these, that, whatever I said you just now. So from this you can find out your maximum wheel load MA when you know all the values here. Okay, so in this way you can find out or calculate your maximum bending moment. Fine. So maximum bending moment, and where is the maximum bending moment? Here, when your uh, distance of the CG of the entry girder is at an equal distance from the nearest wheel to the CG of the wheelbase. Okay, so this was one of the important thing which you should know. Next, if we, okay, fine, we have 5 minutes. Okay, someone has given a comment. Solomon. Ma'am, so the maximum bending moment should always be on the wheel closer to the CG of the gantry girder. Yes, yes, because and you have to place your this wheel base in such a way that these two distances are equal. Okay, you can, if your this distance of the wheel, suppose this is nearer to the CG of the gantry girder, so it can be here. Okay, but if it is here, your CG have to be moved, but you cannot move your CG. Obviously, CG will be same for the gantry girder. So you have to move your wheels. You have to move these two wheels and bring on that place, because if you bring your wheel, suppose here and here, your CG of the wheel will come nearer here. So whatever is this distance, the distance between these two, the CG of the gantry girder and CG of the wheelbase must be the distance of the nearest wheel, whichever it is. It may be this, it may be this, like here I told you. In this case, your maximum bending moment is here, which is nearest to the CG of the gantry girder. But mind, keeping in mind that the distance of these two, the CG to the nearest wheelbase and the distance from the CG of the wheelbase and the CG of the CG of the gantry girder and the CG of the wheelbase are same. These distances are same. You will never get your maximum bending moment. You'll never get your maximum bending moment without this equal distance. Okay, these two distances must be equal in gantry girders, where you will have your maximum bending moment. Okay, Solomon. So I thought of moving with the question, but I think we cannot start now. So in the next class we will take a question on the gantry girder. We'll design a gantry girder if we can. I don't think it will be lengthy. Your design of this gantry girder will be lengthy. Okay, so this will be lengthy. So we'll start in the next class, and your attendance please give on the group. There, I'll take your attendance when from roll number 1 to 49. You can give your attendance now also in the group, and once we complete roll number 1 to 49, I will take the attend. I'll ask you to. I'll ask roll number 52. I think 159 it is over. So till there, I'll ask you to give the attendance, and please give your attendance at that time. Okay. Okay. So thank you. We'll meet in the next class.
What about attendance, ma'am?
Just now I told you. Hello.
You will take our attendance from 1 to 49 or 50 something, no, ma'am?
Yeah. In the WhatsApp group, you just give the attendance from 1 to 49 now. You can give. Once we complete till
Oh, okay,
49,
ma'am.
I'll ask you to give your attendance.
Okay, ma'am. I thought over here, ma'am. Thank you, ma'am.
Okay.